Now I guess we know all what we need to know about moment of inertia with respect to your exams, but I'll just give a small talk, add on to what all we have learned by discussing this. Say we have a rectangular plate. It's a rectangular plate with dimensions A cross B. This length is A and this length is B. Now if I ask you what is the moment of inertia of this plate across this axis, mass of the plate is known, is m, what would you say? What is the moment of inertia? Now this talk is about along the axis I study the distribution of the mass. Along the axis, when it keeps on going deeper, your B increases and A is the same. So had I asked you what is the moment of inertia of the small piece of plate, hardly having any thickness, so very small thickness, delta B, what is the moment of inertia of this piece? And the mass of this piece is, say, delta m. What would have been the moment of inertia? So it will have the moment of inertia of a rod, because the cross section dimension is hardly anything. So that would have been, the delta I would have been 1 by 12 delta m into a square. This delta B never came into picture. So if I keep on adding rods like this of delta B thickness, then what would be the moment of inertia of any given rod, say this one in between? That will again be 1 by 12 delta m a square. So what will be the moment of inertia, the whole thing? That will be summation of all these moment of inertias. So we'll see that B never comes into picture and it will be 1 by 12 m a square. So what I ask the students to remember it is by seeing the axis is cutting which side. The side which the axis is cutting, that square will happen. So 1 by 12 m a square, a is the side which it is cutting, and along B it is growing, so along whichever side it keeps on going, that never comes into picture. So that holds good for 3D body also. So quickly tell me, if I had asked you about this axis, what is the moment of inertia I about this axis of the body? So what is it? It's cutting B and it's just going along A. So A will not come into picture, B is being cut. So this will be 1 by 12 m B square, mass being the whole mass of this thing. Okay, answer this one. What is the moment of inertia about this edge, this axis? So what is the moment of inertia about this? The body is going like this. So what will it be? Again, along the B, the shape is not changing. So had it been a thin one like that, the answer would have been 1 by 3 delta m a square. So the whole thing will be 1 by 3 m a square. So I hope you are getting it. Along this will be 1 by 3 m b square along this. So if along an axis a body is growing without changing in dimension, means say along this axis the body has gone down symmetrically both sides. It has gone down in the same way as it was in the initial part. It has not increased in breadth or anything. If it increases, then obviously this cannot be applied. This small length, this small dm and that small dm would have different eyes, and you can't just simply add like that. But if it is going with the same dimensions on both sides, then you can do. So that holds good for any body, a 3D body also. Say I'll make a random 3D body. And suppose along the length of the body you have a certain axis. So that's your 3D body. So this is behind. And this axis along the length may not be from the CM. So I'll just take it from anywhere. The center of mass is somewhere here. That's your CM. I'm just taking the axis along anywhere. So if it had a moment of inertia of, this flat thing had a moment of inertia of k times say m and some length dimension square, some dimension of length square, k times 1 by 3 m r square or something. So if that was the moment of inertia of this small thing, then the whole thing will have moment of inertia of same, will have the same format moment of inertia k m l square, where m, this small m, depicts the small mass, this big M depicts the whole mass m. So this we have already known in bodies which we have studied, like a cylinder. So a very flat piece of cylinder on top is same as a disc, and the moment of inertia of a disc, if I call this upper mass, the small mass, as m, the moment of inertia of the disc was half m r square, r being the radius. So moment of inertia of the whole cylinder is also having same format, which is half m, m being the whole mass, into same r square, because along the axis it is not changing. Mind you, in a later on video, I guess we have done the video earlier, mind you, if I do moment of inertia along this axis, I will not have the same format as moment of inertia along this axis of the top disk. The top disk will have m r square by 4, and this one is not going to have, this I is not going to be capital M r square by 4, not at all, not at all. In fact, we have found out what it was. It was having a component of length also in it, and we have derived that formula. So why this axis and this axis is not having the same format? Because the orientation of the body around this axis and this axis is different. Here, if the body, the depth of the body is maintaining the cross section at any given cross section along the axis, it is the same shape, then only you can extend the formula, like a ring or a hollow cylinder. A ring will have m r square as moment of inertia. A hollow cylinder will have m r square again as moment of inertia along this axis, because if I take any cross section, it is going to be the same shape as was the top one or the bottom one. All cross sections will have same shape. So if you have all cross sections having same shape, then the formula remains like over here. All cross sections are having same shape. All cross sections will be having same shape. So I'll just ask you a question on this. In fact, it might be a little interesting to discuss cuboid. So this is a cuboid. Say the dimensions are A, B, A and B same as the top face of the plate is, suppose this one, and the depth is C. Now if I ask you, what is the moment of inertia of the body along an axis which is going through the center down, then can you tell me in the answer I, which of the three will not be figuring, or will all three be figuring? Will C be not in the answer, or B not in the answer, or A not in the answer? I hope you got it right. C will not be in the answer. Why will C be not in the answer? Because we are going, this axis is going along the depth C. So same as explained over here, B was not in the answer. Here C will not be in the answer. So your answer would be whatever this top mass is having the format of the answer with its mass. So that same format will carry for the whole mass. So the whole mass is suppose M, then your M times, you'll have A's and B's over here, and a constant which is same as for the plate. So for the plate, this axis which is going like this is axis like this, going like that. So what would you apply? I hope you understand that you can apply perpendicular axis theorem over here. This and this being along the plane and this normal to the plane. So this one was your 1 by 12 MA square, 1 by 12 m a square, and this one was 1 by 12 m b square. So for the top plate it will be 1 by 12 m a square plus b square. So 1 by 12 m a square plus b square. So small m for the top piece only, for the whole mass it will be capital M. So that will be the answer. Now if I ask you, what is along this axis, which is going along a depth b, and I hope you got the answer. Your answer would be, not having b in it, it will be c square plus a square. So this answer will be 1 by 12 m c square plus a square. Similarly, which is going along a, this would be 1 by 12 m b square plus c square. All three are perpendicular to each other, but I hope you understand that here if I call one as, say I call this as Ix, and this one as, say, Iy, or Iz, this is coming out Iz, and this one as Iy, then your Ix plus Iy or any two added is not the third one at all. It is not the third one. I hope you see that a perpendicular axis theorem is not working over here, because the whole cube is not a laminar body, it's not a flat body. Okay, so I'll ask you to do this question. What would be the moment of inertia along the edge, along this top edge? So I'll just rub off the other things. That's my question, and you have to write in your answer. So I is equal to how much? Mass of the body is m, and dimensions of the body is a, b and c. It's a cuboid. So what is the moment of inertia along this axis, which is along one of the edge, that is the edge b? So best of luck with the question. No need of integration. You just have to use the known values of I what you have and apply the theorems wherever applicable. So I hope you got the answer. The answer was by using a parallel axis theorem of shifting this axis parallelly over there. This was through the CM and the value was so much, plus the distance between this axis and that axis. So what is the distance between these two axes? It is the same as the distance between, if you take the front face, then this distance, that's the distance between the two axes. So how much is this distance? So this length was a by 2 and that length was c by 2. So you have a by 2 square plus c by 2 square under root, or this whole diagonal at a length of a square plus c square under root and half of that. So this distance is a square plus c square under root, half of that whole square. So thank you very much. That's it for moment of inertia. Hope you get all the questions which come under this topic. Bye bye.